Here we go. We're going to talk about the Exsurgo Performance System and the new addition, the Exsurgo Performance System Athlete Report. So, if you do not have the Exsurgo Performance System, be sure you go to eps.exsurgo.tech/sign up and check out what we have to offer there for getting set up on the Exsurgo Performance System. To see the athlete report, let's jump right in and hit data analysis. Once it loads, we know that we're going to do this on an athlete. So we're going to pick one of our teams, Team Rebel, pick our handy intern, and then we're going to scroll all the way down to athlete report. This is still a work in progress, so the instructions are to do TBD. You're going to select at most 5 assessments per type. When you go down here to IMTP, the isometric mid-thigh pull, you'll be able to click on this and then select as many as you want. The one thing, let's talk about what the EPS athlete report is first and foremost. It is a collection of assessments, and these assessments were specifically picked based on research, based on preferences in NSCA textbooks, based on preferences from strength and conditioning coaches that were questioned and queried to find a baseline assessment that was not sport specific but measured speed, power, agility, endurance, all components of various sports. I mean, there's so many different attributes of sports that could be considered, but we wanted to find a collection of those that could be represented across multiple sports and then compared, so that we could then look at comparisons of individuals of specific sports, between different sports, age groups, genders, you name it. So back to this. This is the culmination of all that work, and it allows us to then create this report, taking all of these different assessments, compile them together in one easy place without the use of any spreadsheets. I cannot tell you enough, I cannot stress enough how many spreadsheets we have all created. There are tons of spreadsheet videos, there are tons of how to create Google Sheet videos. It just goes on, and it gets to a point where let's not be engineers and architects of data administration systems. Let's be coaches. Strength and conditioning coaches with valuable skill sets that are not always tech related, maybe more athlete oriented, athlete centric, and customer facing. So again, this is to make our lives easier, right? This is not to complicate things, take away old systems. This is, or replace people. This is to make our lives easier. This is to make it so that we can do what we do best, and that's coach, and that's help athletes grow and develop. But this helps give us accurate insights into the areas that we should focus on to help them get where they need to go. So let's jump right in. As I mentioned, many different assessments. We're going to start with the isometric mid-thigh pull here. We'll just select, it looks like 6'6" has a good number. That tells us we've selected 5. Next, we'll click on IMTP RFD. These are from 526. You can compare the best efforts from different times. Not sure how valid that is at the moment, but seeing that all of these are really from 526, perhaps I'll go back to the IMTP one and deselect these. Should probably have a deselect all button. And just select the 526 efforts. There we go. There's only 4 of those. That's okay. They get averaged out. Then we'll jump into the select counter movement jump, drop jump. This 9,190 inches, that is massive. So we're not going to select that one. We're going to disregard that and select these here. I try to keep these in sequence, primarily because that's the order in which the tests were done. We do not have a 526 for this, so is that true? That is true. So we will just take, we'll just pick four most recent ones and go with that. So now these are all selected. We're going to scroll down. Oh, split distances. The sprints were 20-meter sprints, and we put a split gate at 10. So we're putting in the split distance here, and you'll see why in a second. Look at this lovely button. We hit generate. So we've removed going through and exporting data from, say your force plates, and then taking data from your speed gates, and then taking data from somewhere else, and we then putting it into, you either put it into a spreadsheet or you're putting it into an athlete management system. Each one of these things all has costs associated with them, and with the Exsurgo Performance System, all three devices connect to this and allow you to use that data to generate these reports for just the cost of the Exsurgo Performance System. You either pay it yearly or monthly. But that's, I think, a lot better than having three different providers, one athlete management system, and in some cases those could cost over $250K, right? We're trying to get stuff to work together, and hopefully this helps. Hopefully. So let's see what the results are of the report. Here is our strength. We're looking at a strength to weight ratio from the isometric mid-thigh pull, strength to mass ratio, I should call it. Coming in at a 2.337. That means the amount of force produced from the isometric mid-thigh pull is divided by the mass of 190, resulting in a 2.33. Research that I did shows that most athletes that we assessed, who were travel team, lacrosse, soccer, field hockey, come in at around 1.8, so this is great. Verkhoshansky once was asked how much strength and power is enough, and I believe his response was, when you're able to do the things you want to do the way you want to do them. If he didn't say that, or if I'm paraphrasing, I apologize, but that's really what it should be about. Strength is a component, but too much strength and not enough rate of force development, rate of production of said strength, leaves us slow and strong, which isn't a bad thing if that's your sport's needs, right? So then we have the RFD strength ratio, which is the rate of force development divided by the force expressed in a maximal force. That's taking the IMTP RFD down here, dividing it by the IMTP, resulting in, hey, I'm utilizing 89% of my maximum strength in under 200 milliseconds, which I think is another interesting component. People who are lower, maybe it's 50, maybe it's 60, they're probably not performing as well as people who are in the 70s, 80s, and 90s. Again, it's another ratio that we're looking at, strength components. Then you have a relative RFD ratio, which is taking the expression of force in under 200 milliseconds. This one is sampled at 112 milliseconds, and dividing that by mass, body mass, resulting in a 2.091. Still well within what we saw other athletes performing, high-level athletes, youth athletes, I should say, not collegiate. Some of them were just going into college, end of high school, rising collegiate. So then we jump into this. This I think is super cool because this takes the highest jump of the counter movement jump. It takes that flight time and then calculates takeoff velocity, force in newtons, power using the Sayers equation for the squat jump, and then using the Sayers equation and the reduction for the counter movement jump. They're displayed here. That allows you to see, some insight. It's not what you would get from force plates. It definitely is not what you would get from force plates, but it is a little bit more than what we were offering before. and we hope this helps people understand more about what they're doing when people are jumping. We then took the drop jump and divided it by the counter movement jump to see more about the stretch shortening cycle, eccentric utilization ratio, and then offering that here as a ratio again and a percentage. Then we jump into dynamic strength index. You saw up here we were working with strength. This is from the G strength. This is the jump analysis. This comes from the G flight. You can take both of those and compile them here to put together a score. This was brought to us by a great person who helped us, Christopher Cervantes. It's fantastic. This will give you, again, ratios. So I think you can start to see that we're looking at a trend here of ratios. What is the optimum relative strength ratio? What is the optimum rate of force development strength ratio? What are we looking at in terms of dynamic strength index, which is force produced from the isometric mid-thigh pull to the counter movement jump? I think it might be interesting to look at rate of force development from the isometric mid-thigh pull to the counter movement jump and see where we net out there. That could be an interesting study. But those take the G flight and the G strength data and puts it right here and delivers that to you in a very simple, easy to digest way. Here we drop into the sprint. This is data collected from the G Sprint through the Exsurgo Performance System app. All of these are collected through the app. The app is free for an athlete, and then one price gets you unlimited teams and athletes. It's really kind of fantastic. If you did splits, which we did, specified one was at 10 meters. We specified the total distance was 20 meters in the app during capture. This will calculate for you the split times. So 0 to 10 took 2.32 seconds. This is acceleration. I wouldn't call it max acceleration because the athlete would probably still be accelerating well past 20 meters. However, you can see the difference between the 10 to 20 meter split is almost a second less, and that's primarily because we're looking at a massive increase in meters per second for velocity, which would still be acceleration at this point. I'm pretty sure max acceleration isn't reached in high-level athletes until around 40, 50 meters, maybe. I think some elite levels are still accelerating even 80s and 90s possibly if they're slow to get going. Then you have the total time for the 20 meter calculated here, as well as the meters per second so that you can see the difference between those gates. That could be insightful for someone, for a coach, to say, hey, maybe we should look at increasing acceleration versus increasing velocity. There could be different training modalities for acceleration and velocity. And then finally, we're going to jump into, this is misnamed, but it's the reactive strength index, which we know and love, primarily because what we're looking at there is the data from the G flight from a drop jump, where we are looking at jump height divided by ground contact time. Research put together these spectrums, if you will, to identify areas of training development if needed, maximal strength training, plyometric training, things like that. There would be recommendations made. Coaches could use that data to determine where to increase. Again, as I think you're starting to see this picture, we're looking at ratios of different qualities an athlete could possess, and then using those ratios to kind of formulate a picture of what to improve to kind of guide us. If I looked at this, I see that we have a 2.5 reactive strength index. It's putting us in optimal. Actually in exceptional, right? So we're just at the bottom end of exceptional. I look at ground contact time, right, and where that compares. What we're looking at here is 128 milliseconds. That's going to be somewhere between max speed and acceleration. This is captured from the drop jump as well. These are in seconds. We need to fix that, but that would be 440 milliseconds to 720. That's change of direction. NSCA textbooks have ratings of, how much ground contact time is taking place during change of direction, agility, acceleration, and max speed. And so you can kind of see, again, we're looking at these ratios. Are we off the ground fast? If we're hitting, in a drop jump in the 5s, we need to work on a few things there. If our reactive strength index is lower, what is the recommendation? Is it concurrent plyometrics and strength development? If we're looking at sprints and we're saying, hey, the end result is we need to work on some acceleration. We don't have to stay too hard on the velocity. There's different types of training for each one of those components. And again, looking at the dynamic strength index, this is painting a total picture of what the athlete needs. And it's to help inform coaches so that they can say with more clarity, backed up by data, that, this is the training program that I recommend for, athlete 1, 2, 3, and 4. I recommend a different one for athletes 4, 5, and 6 in order to get them to possess the qualities that might be desired for their sport. For the general population, I know we've been talking about athletes, but for the general population, when we drop into this right here, just a simple assessment of isometric mid-thigh pull to weight will give you a relative strength ratio. And pair that data with percent body fat and skeletal muscle mass, for the general population, you could have a roadmap that shows you, hey, is this, do they need overall strength development? Do they need body composition modifications, in the form of nutrition? If someone has a high percentage of body fat, if the desire is to have lower body fat percentage, is training that and not adjusting their food intake proper? I'm not sure. It would vary based on each individual, and you'd have to take a look at what they present with ultimately during an intake assessment. I know this sounds kind of clinical, but the thing is strength and conditioning, can be a lot more than where we are currently. We can do a lot better, right? It's not just everybody get strong, everybody get fast, living our lives, La Vida Loca on social media, being, Fisher Price, my first strength coach package. So I think there's a lot that we can do with this from the general population. This could help trainers. I think there's a lot we could do with this, from a youth athletic perspective to look at appropriate, loading schemes, metrics, body composition. If you're seeing an athlete that's starting to get heavier in a good way, but maybe they're in a weight class and you need, to understand, well, I keep lifting them and they keep getting bigger. Well, maybe we don't lift them. Maybe we, try something different that keeps them, at their, peak performance at fitness level. Maybe we're looking at nutrition strategies. Maybe we're looking at different developmental programs where we're changing, the exercise modality often, because the body responds to all of that when it's, a lot of things changes in a great way, because what we're really looking to do here is to help coaches do their job better so that athletes can go out and play their sport or live life better. That's it. We all just want to live better. How can we do that together? Find out more on the next episode of Exsurgo Performance System. All right. Thanks for listening. If you made it this far, awesome. Feel free to tell me I sound really funny. All right. Thanks. Bye.